Good evening, all. Uh, let's start the demonstration lecture of the separator.
Hi,
Hi, everyone. Good evening.
good evening.
Good evening.
Okay. Good
Good
evening. Good
evening,
evening.
everyone.
Yeah, hello.
Yeah, good evening, everyone.
Okay. Let's start the session. Today we have a demonstration lecture of the oil and gas separator, and same we will be learning specifically a type of separator, and according to the we can do sizing and we can try to sizing the two-phase separator even horizontal as well as vertical. Okay. So if you have any question, just raise the hand. Okay. Now, generally we know the separator itself word says that separate out something. Okay. Separate out of liquid uh, from the vapor liquid liquid, even sometime vapor liquid liquid solid. So if you have seen a two-phase, three-phase, four-phase separate are there, and according to the requirement, we will do the sizing. Now today we are going to be learn basic guidelines and types of temperature classification of separators and basic thumb rules and their formulas how to size the separator. Generally, API 12J, Shell, DP, then GP, Aramco, individual company has their own guideline to size a separator. But as per API 12J is the a standard guideline to size the separator. Okay, so uh, other guideline we have to size like Dell GP, Aramco, ADNOC, right? So according to the formula is the same for when we are sizing the separator. Okay, nothing is different, but only just residence time and tripping time of the pumps and tripping time of the valves that will be different. So according to their requirement, we will size the separator. Okay, because main thing in the separator is residence time. Okay, and traveling time. Now classified a separator is defined based on the different four sections. First is the two-phase based on the phase. Two-phase, three-phase, four-phase separators are there. In the two-phase, as we know, liquid, liquid or vapor liquid are there. Three-phase vapor liquid liquid are there, right? And four-phase vapor liquid liquid and solid are there. So second thing is the based on the shape. Separator based on the shape is horizontal. In horizontal, we have a vapor liquid, even liquid liquid too. Same for the vertical vapor liquid and liquid liquid. And spherical. Generally, spherical nowadays no one can use. Mostly vertical and horizontal separators are there. Where to use vertical and separator and what criteria we can see in the later stage of slide. And based on operation pressure, what are the types of pressure and where to use, because pressure is also defined the demonstrator requirements and other internal sizes. Okay, so low pressure separator, high pressure separator, intermediate separators, those are we have a range. Okay. Please mute yourself, please. And based on the sizing method. So now generally we have a two type of sizing methods are there. First is a droplets settling theory method, and second is standard round approach. Right, both the methods are there, so we can see where to use and when to use. here is some of the classification by phase. If we have seen previously, vertical separator, two-phase vertical separators, three-phase vertical separator. In horizontal, which we have a two-phase and three-phase separators are there, right? In the three-phase separator, boot type and wear type is the most important thing. Right, boot type, when we are using boot type, when we have a second liquid margin or second liquid flow rate is less than 5% of the total flow of the liquid. Okay, at that time we are going to use a boot type. Otherwise, we will have a wear type. Okay. Generally, what are the classification based on the pressure? Generally, up to the operating pressure, 10 to 20 to 2 to 225 psi. Uh, okay, the operating pressure range between the 230 to 250 up to 700 psi, and for the high pressure above 750 psi to onwards. So this is the pressure requirement ranges. So according to, you can also classify it based on the pressure operating. Okay.
Uh, uh, Hello, can you unmute? Couldn't hear your voice. Huh?
Hello, can you unmute? Hello.
I think you are on mute. Can you unmute your audio?
Okay. Okay. Uh, Actually, if you can see here, so whenever drag forces is travel from bottom to top, and gravity force will travel from top to bottom. Okay, so generally the droplet size, a droplet settling velocity, the depending upon three major laws: a Stokes law, which is small droplet particles, and intermediate law, large droplet particles, and Newton's law, which is having very large droplet particles. So all the three have an equation to calculate the terminal settling velocities, right? Now, a major part and major classification is also the depending upon your the flow rate of your system. Okay, if you can see here, some of the factors are influencing what are the droplet size. Generally, factors is depending upon the properties, flow rate, inlet conditions, right? Which kind of material we are flowing, and we have to separate out into the system. Other thing is factor influence separation efficiency, which is a droplet diameters, residence time, which is made. And residence time, generally we can have a table as per the company requirement. Generally API and shell, DEP, GP all should have their own requirement. So residence time will be defined according to their requirements. Then internal sizes, what are the internals? Are there foam breaker, mist eliminators and baffles and other controlling from enhancement and everything, right? Then temperature, collisions, and operating pressure effect on the, generally, if we know the density is equal to PM by RT. So if it is pressure is also major part to play the role of the densities, right? Now here is some basic droplet sizes are there, because droplet size is the main governing factor and main governing key to size the separator. Okay, so if you don't have a droplet particle sizes, so we can calculate it from the above equation, because we have some droplet Stokes theory or intermediate theory or Newtonian theory. We'll see the some formulas how it is belong to the droplet particles directly related to the dosage terms. Okay, so individual, this is the just thumb rule of the diameter of particle, which is defined and derived by the experienced people. Okay, so if you can see entrainment from the water, cooling and spray, cooling tower, spray, then condensate from gas cooler, condensate from intercooler and compression plants. So those are the some diameter of particles. Now, uh, where to add the demister pad, where those demister per requirement we can identify, we'll see in the next slide, because we have some thumb rule and guideline when we are using demister pad. Okay, now if you can see here a major equation of the Standard Brown equation, right? So major these equation, generally we can calculate the gas velocity as per the requirement, which is a Standard Brown equation. Okay, then what are the factors are included to size the separator, or even also what are the requirements to calculate the gas velocity? If you can see pressure will is the governing factor for the density equal to PM by RT. So pressure increases, density increases. So according to the density, the gas density will be changed. If it is gas density will change, so velocity is also changed. If you can see, the gas density is also directly proportional to the velocity, right? So even inversely proportional to. So according to that, we need to decide what will be the pressure. Then fluid property. Again, fluid property is also based on the temperature and pressure. Okay, so temperature has also large impact, because density is equal to PM by RT. Temperature increases, density decreases, because density inversely proportional to the temperature. Okay, but pressure is directly proportional to the pressure. Then separator geometry, vessel length of the liquid level for the horizontal separator. Then steadiness of the flow, inlet device and designs of the performance, relative amount of the gas and liquid flow. Okay, so vertical separator will be used, or horizontal separator to be used based on the liquid by gas by liquid ratio. Okay, so we'll see generally the depending upon the requirement, suppose 60-70% gas are there into the two-phase flow. So generally we choose a vertical separator, but still we have to check the how much flow are there, means the quantity of the flow rate or to be separate out, because I would not say that vertical is a vertical separator is best for the gas, but any kind of flow. We have some flow restrictions and flow requirement for the same. Okay. Mostly importantly, mist extractor type and designs with like mesh pad, van pack, multi-cyclones. Those are the internals. So those internals, we have some specific requirement where to use. Okay. if it is the design parameter of Ks is a nothing but the factor of the separation, right? So Ks, if you can see here, the when we are selecting the case, if you can selecting lower case means velocity is directly proportional to the Ks. If it is Ks is lower, so velocity is lower. If it is velocity is lower, so what will be the area? Right? If it is velocity is lower, flow rate will be keep same. So area will be increases. Area means increases means dia increases. Right? If it is higher K value, okay, then smaller, cheaper, high gas velocity. Okay, everything is to be down because velocity is increases. This velocity increases, then again area would be decreases. We have to design optimum way. Lower K value gives you more diameter. Higher K value gives you lower diameter. But in the case we need a optimum velocity or we need to require optimum U. So K will be designed by the optimum. Now K nothing but the demister pad. If you have a demister pad, okay, we'll see that K value will be directly depending upon the diameter of the particles. Okay, we'll see how generally will K will impact on the other things. Generally, the K value, which is a bare mesh size, bare meshed thermistor pad, K factors are there. So that will be driven and given by the generally vendor, and we can choose it according to the requirement, pressure, temperature, and everything. Right? Like if you can see horizontal K value, vertical, spherical, if it is waste stream, then vapor are under vacuums. So depending upon even atmospheric, depending upon the pressure values, right? If you can see the 1000 kilopascal, so 90% you have to take the value of the horizontal. Suppose if you are choosing horizontal K value 0.12, right? If your pressure is say 2000 kilopascal, so 0.12 into 0.85 is your percentage factor. So whatever value it's come, so you have to choose it for the calculation, and you just take it and put it over here to calculate the Vs, right? Because other details already you have density of the liquid minus density of the vapor divided by density of the vapor under root. Main thing is develop the Ks. Now Ks you have a two option. First, select it from the table from the vendor. Second thing is you need to calculate. Okay. So what is the calculation procedure for that to calculate? So we can see. Sorry. Now, before going to be calculate K value, you need to calculate some basic information like Reynolds number. So Reynolds number has a diameter of particle, but you don't have a diameter of particle, right? So you have a terminal settling velocity. Also, you need to calculate terminal settling velocity because you don't have, right? Then a density and viscosity. So you both the term you have. Now what you can do, you can calculate by using a RE value, right? You can take it RE value, other details you have. Determine all the values, right? Relation between the drag coefficient and Reynolds number is given. So if you can calculate Reynolds number, according to the Reynolds number, you can calculate it the C value. Now, according to the C value, drag coefficient you will have. Now, if you want to calculate the K has a equation, right? Under root 4 diameter of particle and C, which is you need to calculate the K. So diameter of particle you need a drag coefficient, because drag coefficient you can calculate it by using these equations. But before that, you have to be select a RE. You need to calculate the RE. Right now, how to calculate the terminal settling velocity? So terminal settling velocity, you can calculate it by using these three formula, right? Stokes law, the intermediate law, then Newton's law. We can see in detail, we can do the calculations in the detail. Okay. When we have a more enough time, because at least we required to solve the examples 2 to 3 hours it will require to taking by examples, right? Because we have to be calculate all three value. We need to check the value of the which terminal settling velocity we have to be choose, because this is a trial and error basis method. Okay, then according to that, if you can calculate the VT, you can put the VT over here. Terminal settling velocity, you need to be calculate diameter of the particle by using these equations. Okay, and you need to calculate RE. So according to the formulas, if you have a diameter particles and drag coefficient, so you can calculate K easily, right? So these all the methods what I have been explaining you, that is the calculation method of the calculate the K value, right? Now, as I told you, if you don't want to calculate, if you want to select directly from the table, so you can choose it here. That would be very easy, and that value should be nearer to the calculated value. Okay. Settling velocity already affected. So whenever we are calculating VT, terminal settling velocity, so basic criteria are there to calculate the settling velocity of the entrainment droplet of the continuous phase flow, right? So what are the factor affecting such settling velocity, droplet size and shape? As I told you, differences density between the phases, then resistance to the settling means drag coefficient. Drag coefficient is also important to for the settling velocity. What will be the challenges are facing the droplet resistance depending on the settling velocity? Introduce complexity, right? Precise determination is not possible, required approximations. Design approach to minimize the error to independent methods are used to calculate settling velocity in design guidelines. So as I told you, VT, so you need to also separate, or also we can say separate method to use to calculate. Here is the sometimes are there when we are designing, right? Compressor drums and flash drums. So these are the residence time from lower liquid level to the high liquid level, right? We can say surge time. Depending upon the type of separator, if you can see, this is the vertical type separator. Okay, now here is a low liquid level, then normal liquid level are there, then high liquid level are there, then again high liquid level are there. So all should have the residence times and guidelines are there. Some of the company automatically explains so you have to take the value of the 12-inch, okay, for the low liquid level. Then you have to calculate low level to the normal liquid level by keeping this residence time. Suppose your bottom flow rate, it would say, I would say bottom flow rate or inlet flow rate having a 200 meter cube. So according to 200 meter cube, you have to be keep residence time 2 to 5 minutes. So you can take it 2 minutes, 3 minutes or 4 minutes or 5 minutes, and you can size the L by D, size the length and dia. Okay. So according to what for the vertical is governing for the diameter, and horizontal separator governing the length. Length means separations. Okay. Here a diameter you have to calculate. You have to assume the length. Okay. According to the assume the length. So you can have a residence time for the low liquid level to the normal liquid level. Now we'll see what will be the separator selection of the vertical separator. If you can see this vertical separator having terminal settling velocity, if you can see here, we have a two velocities, vapor velocities and liquid settling velocities. So vapor velocity is always lesser than the liquid settling velocity. Then your liquid will be settled down here. Okay. Otherwise, what will happen? Liquid will carry over with the vapor. Vapor will carry over with the liquid, and here you will get the losses of the liquid. So if you have a mist eliminator, so in mist eliminator will trap the liquid over here and again come back to the settle down to the uh, bottom of the separator. Now, if you can see here, we have a different kinds of zones are there. Okay. First zone is liquid gravity separation. As I told you, droplet size. Droplet will pull in the two sections. This is the gravity and one is a drag. Right? Drag will be generally based on the vapor velocity. Okay, so please make sure, can you please mute yourself? Right. Second then is a gravity separation sections. This is the mainly this portion is the separation sections. Right. In this separation zone, settle out the liquid settling velocity as well as vapor's velocity. And this is the main dia to calculate based on the terminal settling velocity ut is equal to Ks density of the liquid minus density of gas divided by density of the gas. According to the UT, Q is equal to UT area, and area can give you the dia. And this dia is important when we are designing a vertical separator. Okay, because length is, we can calculate length automatically, right? So if based on the residence time as we seen above. Okay. Here is the same primary zones, secondary zones, liquid accumulations, okay, mist extractions. We can trap the liquid over here, okay. And this is a disengagement space. According to disengagement space, liquid vapor will travel from bottom to top. Now, how to select, how to calculate the diameter of the vertical separator without demister pad? With and without both need to be calculated. If you have demister pad, we have a terminal, we have a K value, density of liquid or by density of the gas. You can calculate the area first, okay, diameter according to the requirement, okay. Then you can calculate the length too, okay. Same for the, if you have a without demister pad, you need to calculate a first drag coefficient. And as I told you, K value is nothing but a 4 gravity into diameter of the particle divided by 3 into drag coefficient. So this is nothing but the K. If you can see, so this portion, okay, if you can see this portion which is related to the K value, right? And here K value already you have because you have a demister pad. So demister pad can give you a K value, right? And you need to calculate K value if you don't have a demister pad. Okay. Yes, Noor. Hello. Okay. So see one example. Okay, then we'll clear our doubts. Here we have a operating pressure 16 bar, temperature is 48 degree, flow rate is 5120 kg per hour. In that case, liquid has a 10% of the total flow rate and rest of the gas are there. Density of the liquid is 1000, vapor is 11.24, diameter particle is 150 micron. Okay, so based on the 150 micron verticals are there, so we have selected the K value, right? And any other factor is deaerating factor based on the operating pressure, as I told you. So how much percentage we need to multiply if we have a pressure and pressure ranges. Okay, if you can see here is a pressure kilopascal. So you need to convert it into the pressure and you can choose it the deaeration factor. So this factor you can multiply directly with the K value. Okay, so that will be give you the margin of the pressure. Right. So first step need to calculate by using a velocity standard Brown equations. Vt is equal to K density of the liquid minus density of the gas divided by density of the gas. So we have selected the K value 0.07, right, into 0.9, which is a deaerating factor based on operating pressure, into 1000 divided minus 11.24 divided by 24. So if you can calculate it by under root whole things, you will get the 0.59 meter per second. So these, by using a 0.59, you have a flow rate of the all two phase flow, right? You can calculate it to volumetric flow rate divided by a velocity. So you will get the area. Now area will give you the diameter. Okay, so I have taken 50 mm more than the requirement. Yes, Mohammed? Yes, yes. Please ask the question. Yes. Am I audible? So if you are can't audible, so please write it down here. If you have something questions, because I can't hear your voice. You have a raise your hand, but I can't hear your voice. Duba, Bangari, and Mohammed. Wait, if I don't know the particle dia, how can I find the K value? So if you don't have a, okay, look, as I told you, if you don't have a K value, if you don't have a K value, so how you can find it out the uh, diameter of particles? So I have explained the process of the diameter of particle, right? First, you need to calculate the terminal settling velocity. If you can see the laminar flow, right? Now, these laminar flow you have to calculate critical parameters, and then you have to calculate the drag coefficient by using these equations. Okay, and according to these equations, we will get the diameter of particles, droplet particles through a maximum droplet diameter particles to Stokes law. So this is the equation of the calculated diameter of particles. So KCR, right? Viscosity, the density of the liquid, density of the gas, all the formulas are there, right? And here is a KCR. So KCR generally 0.2025 of the K value. You need to choose a Perry handbook according to their the formula which is having to calculate the diameter of particles. Okay, so you need to also choose or select accordingly. Okay, 1 second. Okay, now okay, after calculating a diameter, now major part of the calculation is which is to calculate the height. Now height, if you can see here, are different zones of height. H1 is nothing but the bottom tangent line to low liquid level. So now here is a low liquid level are there, right? Here is a guideline. Now how to calculate a low liquid level? Some of the company using 12-inch, 6-inch, okay, 150 mm fixed. Okay, so those are the requirement to calculate from a bottom tangent line to the low liquid level. Then low liquid level to the high liquid level, H2. That is to be calculated based on the residence time. As I told you, we have a residence time as per the API 12J, or if you can say Shell, DEP, GP, and everyone has their own guideline to calculate the residence time. You have a calculated dia, you have a flow rate, right? So Q U is equal to V is equal to pi D, right, into pi by 4 D into H. So now you have to calculate the H. You have a dia, you have a volume to calculate, because residence time already you have say 3 minutes. Your volumetric flow rate is say 200 meter cube per hour. So how much volume you need to be maintained here for the 2 to 3 minutes, right? You will have a volume, right? You have a dia, so you can calculate. You have only one unknown, which is having a height. So you will get the here height of your vessels. Same nozzle diameter, inlet blow nozzle diameter, which we have a requirement. Then inlet nozzle diameter to high liquid level, we call it a disengagement space. So this disengagement space, depending upon the minimum 300 NB or 0.3 into D. So this is the inlet dia. Suppose if you have a calculated 100 NB line, right? Inlet 100 NB nozzle size. So this 100 NB nozzle size 100 into 0.3. So around 30 mm, right? Or 300 mm, whichever is higher. Understood what I mean to say? So this is the requirement you need to calculate it high liquid level to the feed nozzle of the bottom. Then this is the we have calculated liquid space. Now single demister pad filter. Now H5 is nothing but the we can also call it the disengagement space or separation phase, right? So here we have a requirement. You need to keep 600 mm plus 0.5 D or 0.5 D. So this 0.5 bigger D, which is a vessel dia, right? And 0.5 D, which is nozzle dia, plus 600, whichever is higher, we have to select, right? Same for the mesh pad size. Generally, mesh pad size, we do the calculation, we have 150, we can take maximum 150. If your van pack is used 200 MB, then cyclone deck is used so 500 MB. That we have a separate session in the process engineering. We can do the internal because this is the only basic things are there. We do the calculation of the diameter, length, and everything because we know that all the formula are there, but we have some guideline to calculate, or we have some guideline to identify what kind of internals we are going to use. Okay. Then demister to top tangent means here talking about this tangent space. 150 or 6 inch, again depending upon the criteria and the requirement. Okay. Okay. Yes. Okay, if I get the length of vessel like 500 mm, then this calculation method will be applicable or not? You are talking which calculation or which length you are talking about, Duda Mangari, which if I get the length of vessel like 500, no, 500 length means that is not the separator. I understand what I mean to say. 500 mm, that is not the length. That is not the vessel head. 500 is very less. How you can say 500 mm? What basis you are saying 500 mm? You have to be calculated based on these things, right? Look, this is the we have calculated based on our example. Now here we have H1. So H1 is we have kept 300 mm minimum from shell bottom to low liquid level. This is the first one. Second one is H2. We have calculated 10 minutes, right? So now according to our flow rate, now you can calculate what will be our flow rate. Our flow rate is 399 meter cube. We have taken 399 meter cube and we have a low liquid level to high liquid level 10 minutes. So we have a volume 399, right? We have a dia 2350 mm, right? Now we have only one unknown. Vessel volume is equal to pi by 4 d square, right? D square into H. So you can calculate H easily because we have a two variable and one unknown. So you can calculate a height. So this height is nothing but this height. Okay. Then a H3. This hanging space between the high liquid level to feed nozzle. So here if you can see minimum 12 inch or 0.3 to 0.5 D. Now you can calculate 0.3 to 0.5 D. So diameter is 22,300 or 2,350. So into 0.5. So just calculate what will be the answer. So I would say here is a around 2225 or I don't know 1250 might be. So I have considered 1200 here. Same nozzle diameter already calculated based on the flow rate, right? This is the flow rate of the gas. We do the line sizings and according to the line sizings, we do the calculations. Okay. Then again after the 400, we have a H5. So H5 is the same 24 inch 0.5 D or a 24 inch maximum plus 0.5 D. So this is both are in a one or this. This or this, whichever is higher, we need to select. Same for a mesh pad 200 or 150 NB and disengagement space 150. So you can total out. So you will get a 3900, around 4000 mm length you have calculated. What is the velocity to mention in the nozzle? Look, velocity mentioned in the nozzle, which is related to the guideline, right? What is API based on the 12E? The company criteria should have a two-phase flow because this is a two-phase flow, vapor and liquid. So you have to be calculated based on the rho v square, Mach number, and everything. And what will be the criteria as per the company norms? Company says my velocity criteria for two-phase flow is say 3 meter per second, 4 meter per second. So you have to follow, and you have to be calculated according to the velocity requirement. Okay. And if the PDF H2 is LLL2 HLL, correct. And how about the low liquid or higher liquid just above? And the below the HLL are that what we do. Look, here what you are saying, H2 is LLL, triple LL to HLL, correct. And how about low liquid level and high liquid? It is just above and below the HLL and LLL. For that what we do. Look, that actually we whenever you are low liquid level and high liquid level, that is the action need to taken by the downstream system. Suppose your liquid level H1 is suppose he is a low liquid level. So your action will be taken care by bottom pump. Right? If you want to trip the, or if you need to maintain the liquid level through the level controller, or if you can manipulate with your pump VFD and to adjust the flow to maintain the liquid level here. Right? Same for the above. If you have a more high level, what is mean of that? Your flow rate of inlet is too high, or your bottom flow rate, bottom pump having the issues in that case. Right? Or feed control valve malfunction, or pump delivering more flow than the bottom outlet flow. So you have to take care with that. That's why we are having some residence time 2 to 3 minutes to take the action. Separator having a two kind of function. First is to separate out the vapor liquid. And second thing is to maintain the, to control the downstream or upstream operations. Understood what I mean to say, Sakib? So here you need to understand, right? So understanding is whenever we are separating and whenever we are putting or taking the velocity or a residence time, right? Those are based on the requirement, and company to company requirement, operational philosophy requirement are different. I have taken 10 minutes because some of the company are taking 10 minutes. Some of the company are also following 5 minutes, 4 minutes, depending upon the availability and requirement of the situations, right? So that's why we required low liquid level times and some lengths, and same for the it is applicable for cryogenic separator. Its separator is, I'm not saying cryogenic. I am looking for the vapor and liquid only. If it is any kind of gaseous, any kind of liquids are there, right? So here, just consider here a separator as a separator, vapor gas or a liquid, right? Do not consider cryogenic or ammonia or any other things. The sizings and rules and regulations are the same. If you are using hydrogen, LPG and natural gas, so you can do like this only, right? Separator doesn't identify or doesn't uh, take care of your cryogenic. Separator only understand I want to separate out vapor and liquid according to the guidelines. Okay. Okay, when do we consider rho v square criteria for nozzle sizings? Look, nozzle sizing criteria actually look that will be, it doesn't relate it to the separator. That is the related, but What I mean to say, if you can thinking only the Roe square criteria can identify, no, Roe square criteria generally we can have a vapor, even liquid, even vapor liquid too, and that we need to follow. Okay, so that is based on the guideline. We do the calculations, Roe square criteria for the nozzle sizings. So velocity calculation based on the line sizing criteria or any special for a code guideline. No, you do the line sizing criteria, whatever you do the line sizing for a gas, liquid, two-phase blow, that same you have to follow into the when you are sizing this line, right? This is the line. This is a doesn't different thing than the others. Okay, so you have to follow the same guideline, same Q is equal to UA, then delta P equations and other whatever guideline Kings, Biggs and Billy equations, you can calculate it. Okay. And how to we control the field and bottom flow rate. Look, that we have to provide the control wall same as like fundamental. Suppose if you are discharging the pump, so you can put control wall here, level controller, and provide the control wall over here. Or if you are not flexible with the control wall, so you can directly connect these soft signal with the pump VFD. So your according to your level, pump VFD will adjust and flow rate will be automatically will reduces. Okay. And yes, sir, got it. If so, if I want to calculate height between high liquid level to high liquid, so I take 2 to 3 minutes residence time and calculate height. High liquid level. Okay. Your answer, your whatever you are saying, Sakib, right? That is right. But depending upon criteria, some of the company taking only 300 mm, 600 mm, or 1 feet, 6 inch, 12 inch, or what you are saying 2 to 3 minutes. The same formula you have to be calculate a height, volume is equal to pi by 4 d square into h. So you have a two variable diameter and volume you have, and then you can calculate the height based on the residence time. How to define the label for a H1, H2, and H7. Already I have explained. Okay, ask to the ask to the coordinator, so they will share you the PPT. Okay, or you can take it snapshot for to understand how they will calculate it. Okay, already I have explained the here is the formula and guidelines are there on this table. Also, it may change according to the requirement. Suppose some company says no, this is not 0.5D. I have to calculate taking 0.45, 0.4. So you have to follow the same, right? So these guideline company to company, the require based on the requirement, they will change, right? But fundamentals and steps are same. The calculation formula for dia are same. That will be not be change of any kind of guideline, right? The for the calculation of the length, steps are same, but only the deviation into the changing the some of the residence time, some of the heights, thumb rules and fixed levels and all. What does this demister do? Demister will trap the liquid, right? Vapor at the time of vapor velocity is too high, and whenever we are splashing into the vessel, some of the light moisture, light diameter particle of the liquid will carry over with the vapor. So they will trap and again send it back to the bottom of the vessels. So what demister they can do it. This calculation is also same for the dynamic separator or a different calculation. Look, dynamic separator calculation will be the same. Dynamic separator fundamental is different. That will be controlling options. Okay, that will be controlled. That is a controlling option dynamically, because dynamic, what are you saying? My level is fluctuating inside the separator, right? That is called the dynamic. So that will be not impact on the calculation. Okay, that you have to do the PTS calculations, means time calculation you need to when it will require empty out from the vessels, when it will be filled from the vessels. What are the key design and sizing changes required for three-phase separator when compared to two-phase separator? Look, in the three-phase separator, okay, we'll see on later because it will be take too much time for that. The which software should we do the separator? SEPCAL calculations are used. SEPCAL. SAPCAL is a software which is used to separate design, but nowadays software calculation, okay, that up to you. It's for the company requirement. How company will afford? Okay, company will afford the software, that is okay. Otherwise, we'll use the Excel sheet. That is enough. Okay. Let's go to the some next horizontal separator. Now, in the horizontal separator, where to use high liquid flow rates are used, right? At that time, we can use a three phase separator, or even vapor liquid separator also we can do, even vapor liquid separator also we can do, even liquid separator also can do. But the liquid flow rate are higher, and mostly the fundamental of the horizontal separation, which is traveling, right? How it will be travel, I will explain you in that case. The same fundamental which is applicable for the separation. If you can see primary and secondary separations, it's the primary chamber. Whenever vapor liquid are going into the from the top of the section or even side of the vessels, okay, the heavier liquid settles at the bottom while gas vapor will be move upward. So now you need to understand, when you are pushing vapor liquid flow rate, so liquid has a travel from like this only. So this is a generally vapor, right? And liquid will settle down. But when it is liquid settle down, so there is a gap. Directly, it will not be settled down. It may have a will carry over with some of the liquid with then and then settle down. So we have to be travel. How it will be travel, we can see in the next slide. Right? Droplet removal, I mean demisting means liquid is removed by the demister before gas exiting through the top outlet. So whenever, if you can see here, now this is the exit outlet of the system, right? When you have a vapor and liquid is separate out, so here is the exit. So that will be a liquid is removed from the demister. Here is a demister, okay? That will be also trap the vapor, trap the liquid here, and again collect from here too. Okay. This is third one is the liquid collection and discharge. Liquid exit through the bottom of the vessel. Okay. So this is the majorly how three phase or two phase horizontal will work. But main thing is two phase horizontal separator, even three phase horizontal separator, which is traveling length. Effective, we call the effective length. What we have seen in vertical separator, diameter, right? And what is the major part of the horizontal? Effective length. Effective length means if you can passing here a two-phase flow, vapor and liquid, above vapor and then liquid two-phase flow. So liquid will not be drop it directly, because a vapor is traveling from horizontally to try to remove from a vent or remove from the top. But sometime, if you can see here, vapor is going horizontally, but liquid need to be fall down. So what vapor is doing due to the vapor higher flow rate, medium flow rate, high pressure, high velocities. So vapor is trying to carry over liquid with them. So a droplet length will be changed according to the pressure and velocity. I'm not saying my liquids directly down it from this length. It may have a this length, it may have a this length, it may have a this length. Right? That's called effective length of the separation. And this is the major part of the horizontal, and that we need to calculate it. Understood? If you can see here, right? Here is a FB. FB is a buoyant force will be applicable, and then terminal settling velocity related to the gas. Right? If you are thinking my liquid directly drop it down, no, my liquid will drop down from here, this angle only. And this is the angle which is you need to calculate. Am I audible? Hello? Hello? Hello, am I audible? One second. Okay. Okay. So here is the effective length of your system, right? For the two-phase separator. So now we are going to calculate, or now we are going to how it will be. Separations are important when we are calculating with or without demister pad. One second. Huh? First, horizontal separator with or without demister. Okay, same. We need to calculate the terminal settling velocity. Equation is the same as above what we have seen, right? Here is a L by 10. We need to calculate a settling velocity, or if you do not have to calculate in the same, so you can remove it, calculate the VT. Same, you need to calculate the diameter as what we have calculated for the vertical separator, right? Okay, after that you can use it these equations for the length, right? Flow rate of the total flow rate of the system 4 by pi by 4 d square, right? You will get the length, right? I have just solved it out for these equations. If you need to directly calculate a length, you can calculate it. Or if you want to calculate first VT as per the what we have calculated from the standard Brown equation, you can take it this equation, you can put it over here. You as per this equation already you have calculated the diameter Q is equal to UA. Then you can calculate the length, right? And same practice which we have to follow without demister pad, what we have already followed during the vertical calculations. Understood? So same, nothing is different in this case, right? Only the functions and only the systems need to follow, and rest of the equations are the same. Wait a minute. Someone has a calculations. Please share your screen. Already I have screen. My screen दिख नहीं रहा है क्या? Okay, sorry. My screen is not visible. Okay. Now, as I told you, what will be the major impact on the horizontal and with or separator, with or without? Concept is the same, traveling length, right? And yellow, which is a gas, will be movement from same direction. Gas will not be at or condition will or came with or settle over the liquid surface, right? So liquid will drop it down this way. Okay, so you need to take care and you have to be calculate a effective length. And this L minimum, whenever you have calculated the length, those length which is more than the actual length. Suppose you have calculated L minimum say 3000. So you just take it 3200 or 300 like that way. So you have to consider at least 10 to 15% more than the you have calculated the minimum one. Then and then your effective length and separation will be the okay. Okay, so how this same here is a hold up session or hold up interlock, and this is the interlock for the bottom pump. This is the interlock from the top, which is came from X place, right? And this is bottom for the downstream. So interlock, hold up at bottom and surge interlock for the top. So that you have to control raise to R surge and hold up. So that will be the your working zone HLL to NLL. Rest both are the your tripping zone or interlock zone. And this is the disengagement space to vapor to travel from the horizontal way or liquid way. Okay, hello everyone. End of the webinar, we have a QV discussion sessions. Okay. Vivek, you just open my mute access. Okay. Then okay, same horizontal separator L by D. If it is pressure range is like this only, right? Kilopascal gauge and 1700, 1703, 400 or more than 3400 kilopascal gauge. So you have to be choose L by D, right? This is the book references are there. So horizontal for the L by D ratio is a different based on the pressure, same. Here is the calculation method, right? Then all the details we have to put, so like specification of the flow rate of the gas, density, flow rate of the liquid density, Go design factor, operating pressure, operating temperature, atmospheric pressure, hold up time and surge time. Hold up time, surge time. I already told you that hold up time and surge time. Okay. That we need to specify based on the, as I told you, design guideline API 12J. Okay. Then viscosity, diameter of particle, we have to add. If you don't have a, so we have to be calculated. Right. Then L by D acceptable, L by D maximum. Then assume L by D. Right? According to that, we have to be some basic information we need to be calculate. Okay. And rest of the thing, everything has to be calculated. Okay, so here is I don't have an Excel sheet. Will this Excel sheet and will these calculations will be seen for the separator detailed separator sizing lecture. Okay, so we have some guideline or Excel sheet which we will provide by the Chem Club. Okay, that will be authentic, which is used in multinational companies. Okay, and according to that, we will do the sizing as per the input, and we will share with you the sizings. So now, just I am telling you the basic informations about the horizontal one. So generally, what we can get it, we can get the diameter, and we can get the effective length plus maximum marginal length. Okay. Here is the same for the spherical separator sizing. Spherical separator sizing, which is used high pressure services. Liquid volume is low at the time. Then, which is as of now not widely used in oil and gas industry, but even I have not seen in the generally petrochemical industries for the spherical separator. Right. So selection criteria for the vertical and horizontal guideline. If you have a vapor liquid ratio which is more than 5 to 6,000, right, or lesser than that, we can use a vertical. But if it is more than 5,000 vapor liquid ratio, at the time we can use the horizontal one. But make sure here is a gas is dominant flow, here is a liquid is dominant flow. But make sure the flow rate within the range. If you are thinking 10,000 meter cube per hour, 20,000, 50,000 meter cube per hour flow rate is there. In that case, vapor and liquid are more governing. So we are not going to use a vertical one. If you can think vertical one, so vertical length is too much high, right? So we have to be use a horizontal one for the separation, right? Suppose very low. So vapor is too low. So obviously we can, but liquid is higher. So we can choose with the horizontal one. Okay, for the large liquid volume. So same for that. This is the some of the internals are there. This is a deflector baffle, van deffler, right? All should have their own requirement. Okay, mechanisms and pros and cons are there. If you can see, if you can burst deflector. So here is a mist particles are there. Due to the bursting or particle will be particle of the liquid will be drastically changes their shapes. Okay, so it will be converted into the mist. And it may have a chances the gas will carry over of the mist particles. Okay, so here cons is cheap and simple and robust. Cons is very high velocity, violent impact on the droplet of the particles. Right. Here is a good optimistic vane distributor. Right. That will be highly effective over large vessels, even flow distributions. If you can see, flow will not be destroyed. Particle dia is not be cracked or destroyed. So particle dia from throughout the inlet and outlet will be keep same. We'll see in the detail when we have a separate session for the internals. So at that time we can see. Then same for a mesh pad and van pack, both are the same similar kind of things. If you can see K value has a different, then the K value of the van pack is also different. Both the mechanisms and engineering are the different. Okay, where to use, when to use, we can see into the detail. Okay. Here is some design procedures for the general steps, separators, and design guidelines are there. Okay. Here is the same step-by-step formula or a design procedure for the verticals as we know. Okay, so first calculate the terminal settling velocity by using the Snyder-Brown equations, then calculate volumetric flow rate, then calculate the diameter of the vessels, then also separate out the length and surge time, surge volume, hold up time, hold up volume, right? Calculate the total height as we have calculated the above, okay, whole system. Same, how to calculate the nozzle sizes, nozzle dia, everything has to be mentioned. Okay, as what we have seen previously. Main thing is in this two-phase separator, which is disengagement space and disengagement height. If you have a good and proper disengagement height, your separation will be the good into the two-phase separator. Design procedure for a vertical separator. Same, to calculate the total height of the vessel. Already we have calculated everything. Okay. Same for the horizontal separator, little bit the what I mean to say. Hmm, tricky. If I am not say tricky, but it is a complicated one. Okay. So first same, both the volume you need to calculate, diameter calculate, hold of vessel calculate. Okay. Then after calculating diameters and vessels, times and everything, we need to calculate the length because the effective length is most important thing. Okay. For the when we are sizing the horizontal separator. So this is the effective length which we have calculated, and we have a formula to calculate the length, right? Of flow rate of the heavy phase, then flow rate of the gas. Then we need to calculate the area of the hold up time like this. We need some mathematics we have to follow. Then according to that, we get the volume, and volume we can calculate easily length of the system. Okay, we'll do the separate calculation. We do the separate sizing for the same. Okay, acceptable design L, which is more than L minimum. So this is the L minimum. We need a more than the effective area. Okay, now L greater than L minimum, then design is acceptable. If it is length is more than L minimum, then liquid holdup is controlling. So L can be decreased and L minimum increase of the HV decreases, means height of the vessel decreases. So if you can select L more than the L minimum, then diameter will be decreases because L by D ratio already we have fixed. Okay. This case is not acceptable, right? Effective length which is higher than the selected length, which is not acceptable, right? It may have a chances of the mist or vapor will be carried over by the liquid. Okay, same. This is the second step. We have to follow the same equations. So let me show you the calculation if I have for the two-phase separator. Screen is visible. Look, now here is the sizing. Right now we need to calculate here. This is the HV, right? This is the height and length. We have to calculate the dia. So these are the formula which we have selected. So according to the requirement, first, if you can see here, here is your calculations or input data, right? Here is the sketch. Now you need to calculate a diameter. So now diameter is calculated by the software, which is 1.66. So I have written over here 1.7, right? Now 1.7 selected by the after calculations, right? So 1.7, after 1.7, now you can see all the details calculations and residence time calculation based on the requirement, like low liquid level length, right? Then HV length. This is the calculator. This I have selected, right? This is the calculation. This I have selected. Then here a length which is 4.45. So I have selected a little bit more than the what we have calculated, say 4.5. Okay. So I have got the length or residence time and everything. Okay. So now if you can see a length L by D is acceptable, 2.65. I have selected the range at 1.5 to 3. I have calculated 2.65. So now this separator is okay and perfect sizing. You can reach around up to the 3, right? Most important part for this calculation, which is this length. This length 4.37 should not be less than this value. This is the calculated value, right? I have choose 4.5. Little bit more than that. You can also select 4.6, 4.7, but there should not be more than 10% of your requirement. Suppose if you have a calculated 4.37, so you can take it 10 to 15% more margin, like around up to go with the 5 meter length. But don't try to go above than that, right? 10% margin, you can select 4.8. I think this 4.8 value, which is ideal value. So you can reach or you can select up to 4.8. Okay. So this is the some guideline residence time, normal liquid level to low liquid level and normal liquid level to the high liquid level. Company generally given two kind of value, low level to NLL and NLL to HLL, and other company can also select direct low liquid level to the high liquid level. Okay. So this is the basic informations of residence time guideline. This is, I think, typically the API 12J. You can also found in the same one or other kind of resources, Dell, GP, Total Energies, Aramco, ITNOC, all will follow same kind of fundamentals and concept. Okay. So this is the very less to explain you, at least will require 6 to minimum 6 hours to explain whole separator, two phase, three phase, in the three phase, in the vapor liquid liquid, in the horizontal one liquid liquid. Okay, then vapor liquid liquid. So various criteria and requirements are there. So if you have any questions, so you can ask me. What is the exhaustible pressure phase separator? Pressure phase separator, nothing. I think I would like to say phase separator, whatever adjustable pressure phase separator means, I don't get the understand the question, means type of the pressure. And according to the pressure, we can select the Ks value, velocities, and some internals. Okay. Look, in the detailed manner, if you are saying detailed manner of the lecture, look, so everything is not, we are not going to studies uh in the webinar lecture. This webinar lecture to identify you to the what the details we can explain and how we can guide you and how we can size, because I think everyone knows the separator is a very big topic. It will not finish within a 1 and 1.5 hour. We required any other 4 to 6 hours to complete the whole system. Okay. What is the common mistake fresh engineer make design separator? Look, that I'm designing the separator. It's about the conceptually. You need to be understand the generally wave for the vertical can do anyone can do the sizing of the vertical, but when they are coming with the horizontal one, so in the effective length is the most important criteria. Rest are all mathematical things are there, right? Nothing is conceptually. If you are fundamentally good in the separator, you can choose the right values and right Excel sheet or software. So definitely your answer will be match. Okay, so everything is maths here. If I can typically say that. KG Tower software is for the generally column design. Okay, distillation column internal design, and for that in the packing, in generally packing they will select. I don't think so. The KG Tower has a separate for that. No doubt. KG Tower will provide you the internals, but KG Tower is generally typically for the distillation column, not for the separator internals. They do KG Tower, they do the calculations of the separator internals, but they have a separate sheet or formats are there. Horizontal and vertical, which one is the more efficient? I don't think so efficient, depending upon the requirement, space locations, right? Temperature, pressure, what will be the gas flow rate, liquid flow rate? That will be defined you to the, what I mean to say, efficiently. When do we use boot in the horizontal separator? Horizontal separator boot for the generally what we can do, if you have a flow rate of suppose vapor liquid liquid flow rate are there. Vapor has a 20% flow rate of total. Liquid has a say 85% of or 75% of your total flow rate. Only 5% are the second liquid flow rate. Suppose oil and gas are there and oil are there and water are there, right? Gas, liquid, liquid. So in the oil, water is only 2 to 3%. So I would say if you can having a 2 to 3% and quantity is too less, at that time we are going to use a boot. Okay, so that will be help to you to boot to collect from the system, because boot is required when we have a second liquid composition, second liquid component flow is too low. Okay, will the material to be shared? You discuss with the Vivek, they will give you. Sir, knockout drum moisture separator both works on the same principle. Moisture separator, I don't understand what is you are saying moisture. Knockout drum, definitely the equations and everything is to be same, but knockout drum generally will be calculated by as per the API 521, because in the knockout drum diameter of particle of the component is too high, around more than 300 micron, right? At that time that formula, concept, fundamental, everything is same, but that will be fall under API 521. That guideline has to be used based on API 521. What are the most common mistake? Okay, good flow rate is high, but still we design horizontal. Why? For flare R KOD, floor KOD, gas flow rate is too high. Look, actually, as I told you, you can also do vertical, even horizontal, but here flare KOD, which is that's why we are taking the horizontal because the flow rate is too high. Here, I told you, explain you previously, vertical and horizontal should have their own range for limitations, right? You cannot use if you have a good flow rate of the gas and liquid, but you need to also check the what I mean to say, total flow rate of the system. If it is huge, your height is too high, diameter is too low, right? So you cannot use a vertical one. You have to use a horizontal one like 30,000, 20,000 flow rate. Okay, vertical is used for a gas flow rate is high and liquid is low, but that is a limited flow rate, not for all the flow rate. If you are flow rate is 20,000, 30,000, so you cannot use vertical one. Okay, vertical one you can use 5,000, 10,000, that is okay. Okay, 10, 15,000. But if you are going to use 40, 50,000, so not feasible for the vertical one. Can you demonstrate? What if I have a three-phase separator included water? How I can size the boot water? Water, how can I size? What if I have a three-phase? Look, boot, that will have to take the separate session for that, for the boot, because boot needs some calculation, and that will be around 1 or 2 minute residence time. And if even we have some